All right, we're going to get started with our lighted up kit in the Nightlight second month kit from Make Crate. So you'll get your parts out. You've got your microcontroller and your breadboard, hopefully already attached to your acrylic. We're going to use 3 LEDs. I'll be using white ones, but you can use any color that you want. These white ones can be fun because they change colors. We don't know before we plug them in what color they're going to be. We're also going to use some jumper wires, just the standard male jumper wires that we've used before. And we're going to use a couple of different kinds of resistors. One of those is a photo resistor. That looks a little different than the rest of the resistors, and that's what's going to measure our light. And then you should have a number of regular resistors in your kit, and those have varying strengths. So we need to take a look at those to figure out what strength to use. You'll notice that some of the resistors have 4 bands on them, and some of them have 5 bands. In both cases, the 4th and 5th band, the last band, you can kind of ignore that one, and you're mostly going to be concerned with the first 3 or 4 bands on your resistor. So to find a 220 ohm resistor on the 4 band, you're going to be looking for red, red, brown, because that signifies 2 times 10 if you look at your resistor chart that came in your starter kit. If it's instead of 5 band resistor, you're going to be looking for red, red, black, black. That's 220 times 1 using that chart. For the 10K resistor, if it has 5 bands, then you're going to be looking for brown, black, black, red. So that's 100 times 100 to give us 10,000. And if it's a 4 band resistor, then you're going to be looking for brown, black, orange. That's 10 times 1,000. So hopefully that will get you sorted. And if you look at the color of the resistors in your directions, they should help you pick the one that you want to use. Then lastly, we have that photo resistor. Again, that is going to help us measure light. Our next step should look really familiar to you. We're going to power the board by connecting the 5V port, check it out on the side there, over to that long positive line on the breadboard. Similarly, we'll ground our board by connecting the GND port over to the long negative line on the opposite side. That's the one next to the blue row. You may see some other people do projects like this where they connect ground and 5 volt to the same side of the board, and you can certainly do that, but this eliminates any possibility of damaging our board if we wire them up this way. Next, we're going to begin the process of getting our LEDs set up. This should be really familiar to you because you did it a couple of times in the starter kit. We're looking for that long positive leg. We're going to keep that to the right of the channel on our board. That's where, again, we've chosen our power, which is our positive side, and the shorter leg goes on the negative side over by where that black wire is. Now we need our resistor for this LED. So for the 3 resistors, we'll be looking for 220 ohm resistors. If they are 4 band resistors, ignore that 4th band, and for the first 3, you're going to be looking for red, red, brown. If it's a 5 band resistor, ignore that 5th band, and you're going to be looking for red, red, black, black. You can use the chart that you got in your starter kit to verify that. Now we need to connect that LED to the microcontroller, and we're going to do that using a wire, and we're going to connect over to pin 9 in this case. So make sure that wire is in the same row as your LED and check on the side for pin 9. We're going to connect a total of 3 LEDs in this project. So we're going to repeat that whole process for the next LED. So again, positive leg to the right, negative or shorter leg to the left, stick the LED in, and proceed on to the next step. Again, we'll be looking now for that 220 ohm resistor. So red, red, black, black, or red, red, brown, ignoring the fifth band or fourth band. Those tend to be metallic in color and have something to do with the tolerance, which we're not particularly concerned with here. We're mostly concerned with the color and the right resistance through our bands. This LED is going to get connected to pin 8. So again, verify that that wire goes in the exact same row across your breadboard as your LED, and then over to pin 8. Always helpful to check on the side of your Arduino for the pin number. Okay, last LED. So by now you are an expert in how to build a circuit for an LED. So that's great, useful skill. Have it for the rest of your life. Positive long leg to the right, negative short leg to the left. Utilize another 220 ohm resistor. Get it hooked up, matching rows, over to that negative line to ground the last LED circuit. And our last LED gets connected to pin 7 on the microcontroller. So we should now have 3 LEDs plugged into pins 7, 8, and 9 on the microcontroller. And our code will reflect those pin choices. All right, we're all set with LEDs now. Now we get to plug in the photoresistor. So this is similar to our other resistors in that it provides the same functionality. It controls the amount of current in a circuit, but it functions a little bit differently. It doesn't have its own value. Instead, the level of resistance it provides is in response to the amount of light in the room. It does not have a positive or negative leg, so just stick one on each side of that channel and you'll be all set hooking that up. This circuit gets wired a little bit differently than our LED circuits. So the first thing we're going to do is we're going to connect some power to that photoresistor. So we're going to connect it directly to our positive line on the breadboard. So you can take a wire and put it on the right hand side of that photoresistor in that row and then over to the positive line on your board. We then need to connect the resistor itself to the Arduino. We're going to do that on the opposite side, and we're going to connect to an analog pin. That's pin A0, which you'll find on the left side of your Arduino. And the analog pins allow us to read the values coming out of that resistor to see what level of light we have in the room. And lastly, we ground our resistor using another resistor. This is where we use that 10K resistor. So the 10K resistor is going to be either brown, black, orange, if it's a 4-band, or it's going to be brown, black, black, red, if it's a 5-band. Once that's done, go get your code, and we can check out how our project works. So you can see it functioning here. It's probably a little bit hard to tell, but as I'm varying the light in my room, more and more of those LEDs are coming on, and that is how yours should function.